Alright, so welcome. So this is another video on geometric sequences, and in this one we're going to talk particularly about how to find the general term. And we know that the general term is not a specific term or a number that we're looking for, it's actually an equation. So to find the general term, so the first thing we need to do is think about when we have a sequence. So when we have a sequence, we always have a first term, and our first term we can always say is T1. Okay, and we know that in a geometric sequence we have a common ratio, and every term in that sequence is multiplied by the common ratio to produce the next term. So that means we're going to take our common ratio, our r, and multiply it by T1. So T1 times r gives us T1r, and that is going to be our second term. Okay, so T1 times r is equal to our second term. All right, and then we can move on. So we multiplied this by r. That's all we did. Just show that there. Okay, the next term we know we are also going to multiply by r. So T1r multiplied by r gives us T1r squared, because r times r is r squared. Okay, let's show that again. To produce our next term, so just make a little note down here that T1r squared is equivalent to T3. Okay? To get our next term, we take our T1r squared, we multiply it by r, and that gives us T1r to the power of 3, because we know when we multiply with exponents, the exponents get added. So now we have T1r3. So T1r3 is equivalent to our fourth term. Okay? And we can continue. We can just keep going. So T1r3 times our common ratio gives us T1r4. And so on and so on. It just keeps going. And we generate our sequence that way. So we know that if we take a look at this sequence that we've just made, that there has to be an r in every one of them. So when I look at the first one, right, I see that it's T1, but I don't see an r. But if we recall, anytime you have a number to the exponent of 0, it's equivalent to 1. So there is this little secret r here. Let me change colors. Okay, it's actually T1r to the 0. Okay, so T1 times r to the 0 is equivalent to our T1. Okay, and then we also know that r to the power of 1 is equivalent to itself, so it's equivalent to r. Okay, so anytime you have r to the power of 1, which is what happens when we generate our second term, we have r to the power of 1, gives us our second term. So if we have a look at this, we should be able to see a pattern. Okay, the term number is actually 1 less than the term number. So let me just finish this. So T1 r to the 4 equals T5. So if we look at that, we see that T to the 5, r has a power of 4. And if we look at our fourth term, its r in the formula, I should say, is to the power of 3. T3, you guessed it, is 1 less r to the power of 2. Okay, so we know that each term in our geometric sequence can be expressed in terms of T1 multiplied by r, and it's 1 less, right? 4 is 1 less than 5, 3 is 1 less than 4, 2 is 1 less than 3. So our n minus 1. Okay, so to find the general term, you only need to know your common ratio and the value of T1. Okay, Important thing to note is the general term is known as Tn, or T sub n, okay, which equals R, oops, sorry, got ahead of myself there, which equals T sub 1 times R to the power of n1. And I have a strange feeling that I haven't been saying sub before. I've just been saying T4, T5, and that's incorrect terminology-wise. It should be T sub n and T sub 1, T sub 2, T sub 3, T sub 4. So just throw that little correction in there right now before we get too ahead of ourselves. Alright, so just note that in your notes. When you say it, it's T sub whatever the value there is, okay? And that is our formula on how we can find the general term. And what that means is that we can find any term in any sequence if we would like. And it comes in handy if you have very long sequences. If you had a sequence of 1,000 numbers and you wanted to know what the 82nd term was, or the 382nd term, it would be very painful to calculate it out this way, multiplying the first term right on through with the common ratio to find that one. So if you have your value of T sub 1 and you know what your common ratio is, then you can find any term in your sequence.